Good morning to one and all present here. I am Muthuraman of VIT Chennai, here to present the unraveling power of ALDEP and CORELAP algorithms in computer layout design. Introduction. Computerized layout design refers to the use of computer-aided tools and software to plan and optimize the physical arrangement of elements within a space, such as a manufacturing facility or an office or a retail store. So, here a way to improve the efficiency and productivity of the overall utilization of the space by consideration factors like the workflow, equipment, and the safety aesthetics. Now let's see what computerized layout design is. Computer layout design, often referred to as computer-aided facility layout design, CAFLD. It is a process that utilizes computer software and tools to plan and optimize the arrangement of various workforce in a workplace or a office. The primary goal of the computerized layout design is to create layouts that enhance productivity, minimize operational cost, improve workflow, and ensure the safety and comfort of the employees. Let's see the importance of computerized layout design. So, in an ideal workplace, the productivity improvement, workflow optimization, the cost reduction, and the space utilization is much needed nowadays for a maximum profitability. Let us go into ALDEP algorithm. ALDEP algorithm is Automated Layout Design Evaluation Program. ALDEP is a computer-based tool used for evaluation and optimization of physical layout in various applications, such as manufacturing facilities, warehouses, and even offices. It automates the process of assessing and improving the layout design. One of the primary objectives of ALDEP is to maintain the efficient use of available space, which we have mentioned in the previous slides of cost reduction and the space utilization. ALDEP aims to optimize the flow of materials or products within a facility. This involves minimizing the transportation time and distance, reducing congestion, and improvising overall logistics. By enhancing space utilization and optimizing material flow, LDAP contributes to cost reduction. So this cost reduction can be helped in lowering the operating cost, the reduced labor requirements, and improved required resources of utilization. Step 1. Researching resources. Step 2. Cost reduction and space utilization. Step 3. Data collection. Step 4. Simulation modeling. Step 5. Layout variation generation and rearranging of workstation and machineries. Step 6. Layout evaluation. Step 7. Optimal layout selection. Step 8. Output and the analysis. Now let's see what CORELAP algorithm is. CORELAP stands for the Computerized Relative Allocation of Facilities to Layouts. It is an algorithm used in facility layout planning, which is a critical aspect of operations management and industrial engineering. The primary objective of CoreLab is to assist in the efficient arrangement of facilities equipments within a manufacturing or service facility to optimize various performance criteria. So, CoreLab optimizes facility and workstation arrangement to reduce transportation cost and minimal material waste and enhance the operational efficiency, aiming to improve workflow, reduce congestion, and maximizing the space utilization. It also an iterative optimization algorithm that continuously refines the layouts using relationship matrix and objective functions, considering various facility placement combinations to find the optimal. CORELAP considers the importance and adjacency requirement of facilities within a facility or considering factors like material flow or workflow between department or workstation. The algorithm typically offers a visual representation to the facility or layout, aiding to decision makers within their inside layout planners. Step 1, Input of data. Step 2, Initialization. Step 3, Calculating initial cost. Step 4, Iterative improvement. Step 5, Generate all possible interchange positions. Step 6, Select the best interchange. Step 7, Update the solution. Step 8, Update the cost. Step 9, Termination condition. Step 10, Optimality check. And step 11 is the output solution. Now let's compare the ALDEP versus CORELAP. The differences between ALDEP and CORELAP. ALDEP allocates resources to specific locations for optimal distribution, minimal transportation cost, while CORELAP evaluates facility performance based on proximity to demand points for location analysis. ALDEP optimizes resource allocation to reduce transportation cost, while CoreLab identifies optimal facility location based on the demand and performance levels. ALDEP optimizes resource allocation in supply chain and logistic management, while CoreLab aids in the site selection for new facilities like factories or service center or even offices. The similarity between ALDEP and CoreLab is that it employs the mathematical models and spatial analysis to address facility location problems, utilization optimization, and linear programming techniques. Both the algorithms use spatial analysis considering facility geographic location, demand points, and the other relevant factors. The sustainability part is where the ALDEP and CORELAP plays a major role. ALDEP is ideal for companies seeking to optimize their existing distribution network by minimizing transportation costs in their existing facilities, whereas CORELAP is an aid in identifying optimal location for newly planned facilities by assembling the demands and performance of various factors. Now let's look into some problems. CoreLab uses the adjacency method, which denotes A as 4, E as 3, I as 2, O as 1, U as 0, and X as minus 1 as their values. And the selection of the departments to enter the layout is based on the total closeness rating, TCR. The total closeness rating (TCR) for a department is the sum of the numerical values assigned to the closeness relationship between the departments and all other departments. Department selection of CoreLab. The first department placed in the layout is one of the greatest TCR value. If there is a tie, then choose the one with more A's, E's, and I's, and etc. Secondly, if a department has an X relationship with the first one, it is placed last in the layout and not considered. If a tie exists, choose the one with smaller TCR value. The second department is the one with A or E or I, etc. Relationship with the first one. If a tie exists, choose the one with the greatest TCR value. If a department has X relationship with the second one, it is placed next to the last or last in the layout. If a tie exists, choose the one with the smallest TCR value. The next department is the one with AIE relationship with the already placed departments. If a tie exists, again choose the greatest TCR value. The procedure continues until all departments have passed the placement sequence. Example 1. Given the relationship chart and the departmental dimensions below, determine the sequence of the placement of the departments in the layout based on the CORELAP algorithm. Place the departments in the layout while evaluating each placement. So the department sizes are given below of 9: conference room, president, sales, personnel, plant management, plant engineering, plant supervisor, control office, purchasing departments, with their each square feet and number of grids placed. Now let's look into this problem and try to solve it. So there are totally 9 different departments in this problem. So the department relationship and the department are same in numbers. So there are totally 9 different departments here, which are same as 9 different departments here. So let's start from this side. So there'll be given a table for you in the question, which represents the AEIOU and their numbers to find the TCR and placement sequence. So let's start in the simple and easy way. So let's go by a order from down to up, which is first as I. Let's start from here. So let's move from here. So I and then nothing. So then it comes as O to U, like this way, and then EOI, then OOAA, then OOOOO, then then UEOIU. So let's see the same here. I OU EO OOAA OOOO UEOOIU OUUU OUO, 4U's OU double I. So just same as the pattern represent here. So let's need firstly this. So let me repeat once again. Let's start from here. I OU EOI double O double A 5 O's UEOOIU, then OUUU OUO, then 4U's 1O 1U 2I. So I OU EOI double O double A double O double O single O UEOOIU U triple O triple U OUO WWOUII. So this is the pattern which we need to copy in this side too. So same as we did from right to left, we need to start from left to right. So the same thing starts here. I, I, let me erase this one second. Yeah, I, I, O, which is one second. Yeah, I, O, U, O, U, E, O, I, E, O, I, O, O, A, 5 O's, the same represents here, which we have done from right to left. Here we need to do from bottom to top. So what we have to do is, first we need to copy this from backwards, from and then we need to copy here from right to left, and this we need to copy reversely from bottom to top. So the department relationship would have been solved finally with the help of the table given in the question. And now we need to find the TCR value. TCR value can be found out by using the AE, IOU and X given in the question, which is also a default form. So here we need to find the number of U, number of A, number of E, number of I, number of O, number of U and number of X in the straight line given in the horizontal row. So there are 2 I's, 5 U's and 1 O. You can see the same here. Similarly, 1 I, 3 O's and 4 U's. So you can see 1 I, 3 O, 4 U. Similarly, 2 I, 1 E, 2 I, 1 E, 3 O, 1, 2 U, 3 O, 2 U. So similarly, you need to do for all the rows horizontally. So then the summary is completed till now. So how to find the TCR value? So the TCR value given here is found out easily by a single step process. So what you need to do is just see here. There are 2 I's, 1 O, 5 U's. So simply 2 into I value is 2 here. So 2 plus 1 into I value is 1 plus 5 into O value is 0, which gives a value of 5 as total. So here you get 5. Similarly, see, if you are going for the second one, there are 1 I, 3 O, 4 U's. So I value given is 2, O value given is 3 and 4 U. 1 into 2 plus 3 into 1 plus 4 into 0, which gives 2 plus 3 is equal to 5 in total. So you represent 5 here. Let's do the same for the below and complete the TCR table. And now the placement sequence. The placement sequence is the one of the main and plays a vital role here. So let's see the placement sequence. So the placement sequence here is 1 is 5th department. So the placement sequence is 1 for the fifth department, 2 for the sixth department. This actually, the placement sequence refers on the TCR value. So the highest TCR values gives the first sequence for the placement. So the fifth department, which has the total TCR value of 15, the greatest, falls in the first place, and the TCR value of second, which has 12, it goes to the second place, and the TCR value of 10 goes to the third place. But here, why it isn't going to the third place and it goes to the fifth place is it is due to the number of counting here with the AEIOUs. So it takes fifth place, and the fourth place doesn't go anywhere, and the fifth place goes to 10, and the sixth place go to 8, seventh place go to 5, eighth place go to 5, and the ninth place go to 5, as all the three are in the tie, and the first position is given to the first department as priority. So the sequence is 5. The sequence is mentioned here. Okay. So this is how you need to solve a CORELAP problem. So now let's solve the problems in ALDEP. So the department selection basically does in random. So the first department selects as random. Out of these departments which have a relationship A with the first or E, I, O, U, etc., minimum level of importance is determined by the user. It is selects randomly the second department and so on. If no such department exists in the second or completely random, the selection procedure is repeated until all the departments are selected in random and having a relationship with the last one placed in the layout. Not all. Department placement starts with the upper left corner and extends it downward. Vertical sweep pattern, sweep width is determined by the user. Adjacency based evaluation. If minimum requirement met, it prints out the layout and sets some. Repeats the procedure for maximum 20 layouts per run, and user evaluation is must for ALDEP. So now let's begin to solve the ALDEP problem. Use ALDEP procedure to determine the layout vector. Construct and evaluate the layout for the facility based on the relationship chart and the departmental dimensions given below. The dimensions of the facility are 10 into 18. Use the sweep width of 2 and minimum acceptable level of importance E. The closeness values are given as follows. A is equal to 64, E is 16, I is 4, O is 1, U is 0, and X is minus 1024. The table is given below for the unit area and the table for each departments. There are totally 7 departments which consist of receiving, milling, press, screw machine, assembly, plating, and shipping. So the department 4 is randomly selected here. So let's see. Reason for selection: random. The first departments get randomly selected by the computer. So department 4 is selected as random in first, and then it has been E with 4, so department 2 has been selected. Department 1 has been selected as next with E with 2. Then the department 6 has been selected randomly and 5 as A with 6, 7 as random, 3 as. So similarly the layout vector is given below. The layout vector is given as 4, 2, 1, 6, 5, 7, 3. Sweep width as 2. So we need to start our plotting and table. So let's start with department 4 as we have selected randomly. 4 is the first one with the first department. 4 in the full columns filled fully, and in the next two columns it has been partially filled with 4. Then it has been filled with 2 for 10 5 rows plus 5 rows in another side in the next column. So then the remaining is placed with ones to complete the table with 8 into 8 into 8 almost, yeah, 8 into 8. So now we need to find the final layout. To form the final layout, the department is selected again as 6 as random. So we need to do the same thing, do plot 6 as fully for the last end of the table till the end of the table or till the bottom from top, and then again the top bottom to top as partially half filled. Then the department 5 is filled, and then the department 7 is filled, and 3 and 0, and then 3 as last. So department 1 is 30, department 2 is 20, 3 is 15, 4 as 30, 5 as 20, 6 as 30, 7 as 30. So the final layout is here, and the layout vectors are given here: 4, 2, 1, 6, 5, 7, 3. The adjacency score plays a major role in ALDEP problems. So as they have given the A, E, I, O, U and X values, we need to check the adjacency score and find the adjacency score. So the relationship given here are E, I, E, U, A, E, I, U. So the values are given here and we need to plot them and place the value and find the total adjacency score by adding the sum of, which comes to 120 on addition of sum. Now let's have a look into the applications. There are many applications for ALDEP and CORELAP. So certainly ALDEP and CORELAP are widely utilized in manufacturing to design efficient plant layouts, minimizing transportation cost, reducing production bottleneck, and enhancing the productivity in workplace. Algorithms optimize warehouse layouts, conveyor systems, packaging areas, and shipping docks for efficient good movement and material workflow easily, with reduced travel time and enhanced throughout the distribution areas. ALDEP and CoreLab are utilized by organizations to design office layouts aiming to improve employee productivity, collaboration, and well-being by consideration workstations, meeting rooms, and facilities. ALDEP and CoreLab are used in cell manufacturing layout to determine the various things which are commonly used in manufacturing and industrial sector. So finally coming to the conclusion of the ALDEP and CoreLab algorithms. In conclusion, the CoreLab algorithm is a computerized tool that aids in facility layout planning, aiming to create efficient layouts that reduce cost, enhance productivity, and improve overall functioning of the workplace or even offices. It helps the organization make informed decisions about the layout design with the use of technology and the software nowadays. The artificial intelligence is a boom to the industry, which is a major increase in the ALDEP and CoreLab problems, which are can be solved within minutes and seconds almost using ChatGPT and various AI bots. ALDEP is the best suited for optimizing resources allocation in existing network, while CoreLab is used for site selection and facility location decisions and management of new facilities. Both algorithms offer advantages in facility layout planning, but they require improvement to accommodate real-time data, worker preference, and environmental conditions and considerations. A comprehensive approach to port management is essential. Thank you.